Today we're going to be talking about section 3.2, which is on conditional probabilities. So what is a conditional probability? Well, conditional probabilities are a probability of an event occurring given that another event has already occurred. So the conditional probability of event B occurring given that A has occurred is given by this. So we write this as probability of B given that A has already happened. So let's look at an example. Okay. So our first example, it says, two cards are selected in a sequence from a standard deck. Find the probability that the second card is a queen, given that the first card is a king. So we're going to say probability of a queen, given that a king is the first one. So we're actually going to kind of work backwards. So the first card is a king. And so there are 4 kings out of 52 total cards in the deck. Now we multiply that because now we're finding a second probability of a second one, and it's going to be a queen. So there's 4 queens in the deck, but it says assume the king is not replaced. So now we have 51, right? And so when I multiply these, 4 out of 52 times 4 out of 51, I get my final probability, okay? And so let's check our decimals calculator. All right, so 4 out of 52 times 4 out of 51, and we can write it as a fraction is 4. That's 4 out of 663, right? Okay, we could also write it as a decimal, which is 0.006. So not a very good probability, about 0.6% if you write it as a percentage. Okay, let's look at another one. The second one says, the table at the left shows the results of a study in which researchers examined child's IQs and presence of a specific gene in the child. Find the probability that a child has a higher IQ given that the child has the gene. Okay, so if we look, gene is present and a high IQ. That's a total of 33 out of the whole thing. So that would be high IQ given the gene, right? I'll spell it this way. So that would be 33 out of 102. That's another way we can look at this, okay? Is just by looking at the table. So it'd be 33 out of 102. Okay? I'd like you to try these ones on your own now. Now, 2 events are called independent if the occurrence of one of the events does not affect the probability of the occurrence of the other one. So 2 events, A and B, are independent if, and notice it says probability of B given A is just the probability of B, or A given B is just the probability of A. Events that are not independent are called dependent, where they depend on each other. So, it says to determine if A and B are independent, first calculate the probability of B. Then calculate the probability of B given A, and if the values are equal, then they are independent, right? If they're not equal, then A and B are dependent events. So again, we like to think of our cloud example, right? So if we have a cloud and it's raining, right? Okay, and it being sunny out, generally, if you think about it, I know sometimes it happens, but most of the time those are considered independent events. So the probability of rain, given it's sunny out, the probability of rain is equal to 30%, and the probability of rain given sun, right, is going to be probably 0%, right? Raining, given that it's sunny outside, is 0%. So since they're not equal, we would say A and B are dependent events, right? And so if it's raining, it depends on if it's sunny or not sunny out, and vice versa. Okay, so here's an example. It says, decide whether the events are independent or dependent. So selecting a king from a standard deck and not replacing it, and then replacing a queen from the deck of cards. So the question is, are these independent or dependent? Notice we're not replacing it, right? So the probability of selecting a queen from the deck is 4 out of 51. Instead of, if we were to replace it, it would be 4 out of 52. So notice the events are different. They're not equal to each other. So these are dependent, right? We call these dependent, not independent. Okay? Next one, tossing a coin and getting a heads, and rolling a six-sided die and obtaining a 6. Notice those don't depend on each other, right? So we call those independent. Okay, those are independent events. Then, okay, right here, driving over 85 miles per hour and getting in a car accident. So generally, you would know that the faster you drive, the less control you have. And so if you're driving over 85 and getting in a car accident, those would be dependent, right? Your chances of getting in an accident increase every time you increase your miles per hour. Okay, here's a couple guided practice problems that I would like you to try now. We will start with the multiplication rule for probabilities of A and B tomorrow.